Good morning, all. So today we are going to discuss the Neet 2021 chemistry paper. So I am RSR as part of Brainiacs Classes. We are going to discuss this in complete detailed way. Okay. So I hope all of you have written your Neet exams very well. The chemistry was comparatively simple comparing to physics, and biology was also it was simple. So this year we are expecting a good cutoff, but I can say it will be more or less similar to last year's. Okay, since the physics was little bit lengthy, questions were there. So all of you, I hope all of you are ready. Let's start the first question. Okay, so we have the first question in front of you. I hope you could see the question. Okay, so what is the question here? The maximum temperature, okay, that can be achieved in a blast furnace is, okay. So this is something question from extraction of ores, actually, principles and extraction of ores from the chemistry chapter. This is directly from NCERT, and even this question was the similar question was present in Brainiacs model exams as well. So what is the answer for this question? So we know the answer for this question is nothing but our option 4 is the correct answer. Let's say that is up to 2200 Kelvin will be the correct answer. Okay, I hope all of you could see. Okay, so this question was present in our model exams. Okay, I hope all of you have written it very well. This is just a fact based question. Okay, so nothing to work out. So let's see the next question. The structure of beryllium chloride in solid and vapor phase is. So we know beryllium chloride is one of the important compounds that we are learning in our S block elements, and we know that this beryllium chloride in solid state, they exist as polymeric chain. Hope you remembering its structure. So let's understand its structure. So it will be looking like this. Okay, something like this. You have beryllium, okay, and you have chlorine, okay, BeCl2. The other one will be a coordinate bond from chlorine, from another molecule. So you can see here beryllium coming. Okay, you have a coordinate bond coming here, and you have beryllium here. So next one you could see again chlorine, and there is a coordinate bond chlorine. It is going like this. So it will extend like this, and you could see there is a continuous polymeric chain that is happening. So this happens in the solid phase. This is clearly written in our NCERT textbook. Okay, so we can say in solid phase it has continuous polymeric chain, continuous polymer chain. Okay, so in these options they are not mentioning it as polymeric chain. Now in the vapor phase, how it is existing, can you tell me? So it is existing as a dimer. Okay, so it is existing as a dimer. Okay, please remember, so in vapor phase it is existing as a dimer like this. Okay, it's very important. So here I have put the arrow not in the perfect way. Let's say the arrow will be looking like this. So it is something like BeCl2 twice. It will be in dimeric form. So this is in the vapor phase. Very, very important. So let's choose the answer. So the answer will be which one? We know polymeric chain and dimer. So option C looks the perfect answer for this one. Okay, this is present in our Brainiacs material as well. We have in our theory lectures, we have explained it very clearly how the beryllium chloride in the solid state and vapor phase it is existing. So I hope all the Brainiacs repeaters and long-term going students have attended this perfectly. Okay, let's go to the next question. So this is something from our organic chemistry. It was very good question, and from hydrocarbons this is. So let's analyze the question. So you are given what actually? You are given an alkene, that too it's an unsymmetrical alkene. You can see that CH3 CH, you have CH3 like this, and you have CH double bond CH2. This is the unsymmetrical alkene. Why we say this is an unsymmetrical alkene? Because we know that both halves are looking different, and they are doing some addition reaction with the HBr. But we have learned that in the presence of peroxide, so here they have given a compound in addition. Let's draw the structure of that one. You have a C6H5, okay, that is connected to C double bond O, okay, and you have another oxygen connected there, two oxygen molecules outside, you can see that, and that is connected to another carbonyl group, and this is in fact connected to another benzene ring like this. Okay, So this we know it's nothing but benzoyl peroxide. So we know in the presence of peroxide, it will exhibit another effect that is called Kharash effect. Kharash effect or peroxide effect. So what it will do anti-Markovnikov's addition, or we say the mechanism followed here is free radical addition reaction. So here we don't want to do the what we say the mechanisms and all. So just we will do how it happens. Okay. So we have CH3, then you have CH, there is another CH3 here. So CH, okay, correct, right? So you have CH, then double bond CH2 is present like this, correct? Now, on adding HBr into this one, so I have told you if it is Markovnikov's addition, the negative part of the addendum. So we know that this can split like H plus and Br minus. Okay, if it was Markovnikov's addition, the negative part of the addendum will move to least hydrogenated carbon atom. So if you see here in these two, the least hydrogenated will be this one. But we know this is following anti-Markovnikov's or free radical mechanism. So what will happen? The negative part of the addendum will move to most hydrogenated carbon atom between these two. So that is this one. So what will be the answer here? Br will come here and H plus will come and attack here. So the product we are obtaining here will be which one? Can you tell me? Okay, so let's write the product. I hope you have got this answer correct. CH3, then CH, CH3, then you have CH2 and here CH2Br. I hope this is what you have got, all of you. Clear? So what is that answer here? I could see from the options. Options C looks the most perfect answer. 3 will be the answer for this one. So this is also was very easy. This we have done many a times in our daily test and too many times. So please believe, don't worry if you have some marks low also, don't worry, there is a chance for repeating. So I will recommend Brainiacs classes because it was one of the best class where you will get complete infrastructure, and we have complete video lectures offline and online. So in online we are giving complete NCERT based question solving and other important questions from AIMS, Neet, everywhere. So it's a complete package. You can enroll here with complete confidence. So let's go to the next question. So here you have question like this: identify the compound that will react with the Hinsberg reagent. So what is Hinsberg reagent? We know Hinsberg reagent is benzene sulfonyl chloride, correct? So I hope you remember the structure. Okay, that is something like this: benzene sulfonyl, okay, sulfonyl chloride, okay, something like this. Now they are telling which of the compound among these 4 options will react with the benzene sulfonyl chloride, benzene sulfonyl chloride. Okay, then what will happen? What it will do? It will form a solid. I know it will form a salt, or solid will be formed, and thereafter this solid will dissolve in alkali. It will dissolve in alkali. That is very important. So this is a direct question from NCERT textbook. So I am again telling NCERT is your Bible. So we know that primary amines basically RNH2. Okay, if you have a primary amine, then this will react with benzene sulfonyl chloride and forms a salt, okay, which is dissolvable in alkali. So it will eliminate the chlorine and it will form something like this RNH, and you have S double bond O like this with the benzene ring. Okay, so once this compound is formed, this is a salt, we know, and this can be easily dissolved in alkali. Why say it will dissolve in alkali? Because we can say that it has a displaceable hydrogen. Because of that, it will dissolve in alkali. Now the question here is, sir, what will happen if I am taking a secondary amine? So secondary amine, the case is totally different. It will react with the benzene sulfonyl chloride. There is no doubt in that. But the problem here is, you can see here, after reacting, it will form another compound. Okay, it will form a compound something like this RNR. Then you have like this. Okay, then with the benzene ring like this. But here the problem is, further to dissolve in alkali, it does not have a hydrogen is present. Okay, so the problem is it is insoluble in alkali. It is insoluble. Okay, it is insoluble in alkali. So even if you go to tertiary amines, you can see here in a case of a tertiary amine, what is happening? There is no hydrogen even. There is no hydrogen present there. Okay, so if you take a tertiary amine, you can see there is R like this. So there is no hydrogen here, so it will not even react with the benzene sulfonyl chloride. So my answer is which one? It should be a primary amine. So among this, only there is one primary amine, that is here, that is this one. You can see here NH2 group is present only in this compound. So this is a tertiary amine, 3-degree amine, correct? And I know that this is not even an amine, this is a 2-degree amine. So from the options, first one is the correct answer. Clear? So let's go to the next question, all of you. So next one is from, it's an inorganic chapter. Noble gases are named because of their inertness towards reactivity. Identify an incorrect statement about them. So we know that noble gases are inert because they will not react. They have their octet complete. So we know that if their octet is complete, it will not lose any electron or it will not gain any electron. So we can say that there is no positive cation or anion is forming here. So there is no ionic bond or covalent bond sharing is required. So the only force that is existing in them will be dispersion forces, or we say London forces. So the first statement is a correct statement. Now the next one, noble gases have large positive values of electron gain enthalpy. That is correct, because noble gases, they have, for example, if you take any noble gas, it have its octet is complete, correct? So if its octet is complete, let's say argon, we know its octet is how it looks like, 2,8,8, correct? Its octet is complete actually. So what it will do to remove an electron from this one, or to attract an electron, what it needs to do, you need to spend huge amount of energy because this is already stable, correct? So we can say noble gases have large positive values of electron gain enthalpy. That is perfectly a correct answer. That is right. I think that statement is correct. But here their question is asking is identify the incorrect statement. Now noble gases are sparingly soluble in water. We know that. Why? Because we know that they does not have any interaction. Because if you take noble gases, they don't have any charges. Okay, so what they are sparingly soluble in water. They are very less soluble in water because it does not have any reaction with water. So that statement is also correct. Now if you are going to the last statement, you can see here one thing. Noble gases have very high melting point and boiling point. That is comparatively wrong statement. Why? Because we know that from the term itself, they are gases, basically noble gases. So we know that noble gases are very much volatile. They will easily go into the gaseous state. So you don't need to apply huge amount of temperature to get into vapor state. And we also know that since they don't have any interaction or association between other molecules, other noble gases, we can say that they will stay isolated. So if you give a small amount of heat itself, it will go into the vapor state. So I can say noble gases have very high, that is wrong. It has basically very low. It has basically very low melting point and boiling point. So this is the incorrect statement, and my answer is option 4. So I hope all of you could do this with a minimal logic. Okay, all these points we have discussed in our theory class. I hope you remember. Okay, let's go to the next question. It's a very good question. Okay, so the question here is the compound which shows metamerism is. The compound which shows metamerism is. So we know that. Let's discuss something about metamerisms and you will get a fair idea. Okay, so we know that metamerism is exhibited by whom? Tell me. Metamerism is exhibited by polyvalent functional group. Polyvalent FG functional group. So major examples I can say carbonyl group. So if you see, you have 2 valency. That's why we say polyvalent. Ethers, 2 groups are there. Okay, even secondary amines, you can see NH. So all these are polyvalent functional groups. But if you have something like an OH group, okay, so we know that there is only 1 valency here. So this is called a monovalent functional group. Monovalent FG. Okay, so metamerism is shown by mainly polyvalent functional group. Now how the metamerism comes? We know that suppose if you are taking an ether, okay, and if I am taking it like this, CH3, CH2, O, CH2, CH3. This is one example I am taking. I know that here if I am looking at the both side of the alkyl group, we know that we have ethyl here. Okay, here also we have ethyl. Now the same, what is the molecular formula? We can see for carbon, hydrogen 10, and you have one oxygen. Now I can rearrange this in another way, in such a way that CH3, then O, then we have CH2, CH2, CH3. Now here also, if I am looking, I can see the molecular formula is C4H10O. But you can see here, on comparing this one and this one, you can see both are, this is methyl, okay, and here if you see, this is propyl. So I can say, on comparing this one, this is ethyl and propyl, and this is ethyl and methyl. Likewise, if you have different distribution of alkyl groups along a polyvalent functional groups, then we say such a compound exhibits metamerism. Now similarly, if this can be carbonyl group also. Okay, now coming to this question, so let's go to this question. So if you go to this question, you can see the options. We will take one by one option and we will do it. Okay, so in the first option, you can see one thing. Okay, so if you see here, the first option they have given is C3H6O. So let's identify who is C3H6O. So we know that C3H6O. So I understood that this formula looks like CnH2nO. And I know that this is nothing but a ketone group. But if you have a doubt, you can draw a simple ketone like this: CH3, C double bond O, CH3. Now look at the formula. How many carbon are there? 3 carbons. Hydrogen 6 are there, and 1 oxygen. And I could understand same formula, 3 into 2, 6. That's why I am coming at this molecular formula. But here we know that if you look at the distribution, this is also a polyvalent functional group like this. But both of them are methyl group. Can I rearrange it in any other way? No. So you can remember one more thing. You should have minimum 4 carbon atoms. Atoms. Okay, 4 carbon atoms in an ether to show metamerism. And you should have minimum 5 carbon atoms in a ketone to show metamerism. Clear? Let's see one more example, then you will get a clear picture. So C3H6O, you understood that it cannot exhibit what? Metamerism. Now let's go to the next example. I will explain this 4 and 5 in another context. So let's see that. Okay. Now let's say, for example, if I am taking a ketone something like this, CH3, okay, CH2, then C double bond O, CH3. I know this is also a ketone. What will be its formula? C4, then 3 plus 2, 5, 5 plus 3, 8, H8O. But we know that ketone requires minimum 5 carbon atoms to show metamerism. Why? Because here you can see this is again what group? Ethyl group. Okay, and this is methyl group. Now if I am trying to do this arrangement in a different way, like this: CH3, C double bond O, then CH2, CH3. Now here if I am looking it, you can again see this is methyl group. Okay, this is ethyl group. So I can see here both of them have ethyl and methyl, and here also methyl and ethyl. This is just the same compound like this one, because if I am numbering this one, 1, 2, 3, 4, what is the name of this compound? I can say this is butane 2-on. And if I am numbering this compound again, numbering 1, 2, 3, 4. So this is also butane 2-on. So that is the reason why I told it needs minimum 5 carbon atoms. So if 5 carbon atom comes, what will happen? Let's see one example. Okay. So if you have a 5 carbon atom, then I can say the compound ketone will show metamerism. One simple example is, you can see here CH3, okay, C double bond O, okay, CH2, CH2, CH3. So this is a 5 carbon ketone. Now I can say, if I split this one, so this I know this is methyl, okay, this I know this is also methyl. No, sorry, this is not methyl. This is what? Tell me. This is propyl. Correct? Now I can do the arrangement in another way. CH3, I will take CH2 here, then C double bond O, then here CH2, then CH3. So here if you see, then you can easily see that this is ethyl, okay, and this is also ethyl. So here if you see, this is methyl, this is ethyl, this is propyl, and this is ethyl, and both are different compounds with the same molecular formula. So that is the reason why I told minimum 5 carbon atom is required for ketone to exhibit metabolism. Okay. Now let's go to our options. So why I am explaining in detail is so that this will be useful for you when you are learning this again. Okay, so I'm not just discussing the answer and going. Okay, let's go to the next option, C4H10O. We have already done that, and we know that this compound will exhibit metamerism. So my answer here is which one? The answer will be second one will be the correct answer. Okay, now you will also see the third one. So third one, if you see, you can see here this is C5H12. This is nothing but it's an alkane actually. Why? Because that is CnH2n plus 2. And we know that alkanes will not exhibit metamerism because there is no polyvalent functional group. So next one you can see C3H8O. So let's analyze C3H8O. So let's take C3H8O. So C3H8O, if I am looking at, I could understand this is CnH2n plus 2 into O. So from this I could understand this is an ether. So let's write one, but even I don't want to write this because I know for ether to exhibit metamerism, minimum how many carbon atoms are required? 4 carbon atoms are minimum required. But if you see here, only 3 carbon atoms are there. So from that itself, I could understand this compound will not exhibit metamerism. But let's draw it. So 3 carbon atoms. So let's say I am drawing the ether like this. Okay. So if you see here, 3 carbon atoms are there. C3, hydrogen 3 plus 2, 5 plus 3, 8, H8O. This is the formula. Now, if I am trying to rearrange this in another way. So what will happen? I am taking CH2 here. So I am getting the compound CH3, CH2O, CH3 like this. But again, if you see or name this compound, how you name the other? You will choose the longest chain like this. Then I can say this is methoxyethane. Correct? Now here also I am trying to name the compound. I will choose the longest chain. So here also what is connected here? Methane. So I know this is also methoxyethane. So that's why I told both are similar. So I can say this will not exhibit what? Metamerism. So minimum how many are required? 4 carbon atoms are required. So that's why in this example, if you see when 4 carbon atoms are coming for ethers, what is happening? It is exhibiting metamerism. So the answer for this question is, as I told, option number 2. Next question, again it's from organic chemistry. Okay, so I can say this is also from the chapter hydrocarbons. The major product formed in dehydrohalogenation. Okay, since it is dehydrohalogenation, I can say this is from haloalkanes and haloarenes. Of 2-bromopentane is pentatone. This product formation is based on which rule? Hofmann's rule, Haeckel's rule, Zaitsev rule, or even Hund's rule? That's what they are asking. So let's draw 2-bromopentane first. So we know that 2-bromo CH3 CHBr. Okay, then you have CH2 CH2 CH3. So this is my 2-bromopentane. If you number it, you will get it. Correct? 2-bromopentane. Now they are telling this is getting converted to what actually? Pentatone. So that is CH3 CH double bond CH. Okay, then you have CH2 CH3. So if you are numbering it, you could understand this is pentatone. Correct? This is pentatone. Now the question here is how this reaction happens. They are telling it is through dehydrohalogenation. So from that term itself, you will get the answer. Dehydrohalogenation means hydrogen moving along with the halogen. D means removing. Okay, now the question here is, let's analyze the mechanism. What is happening in this question to do the dehydrohalogenation? Now, if you see here, we know that during elimination reaction, the halogen which is connected to which carbon atom? That is called my alpha carbon atom. So nearby carbon atoms are there, 2 are there. So we will call this as beta 1 and this as beta 2. Now the question here is, hydrogen can be removed either from beta 1 or beta 2. Now based on this, we can say there are 2 types of elimination mechanism is there. Okay, suppose if you are removing the hydrogen from beta 1, what is the product you are getting? CH2, then double bond CH, then CH2, CH2, CH3. So we know that the product we are obtaining there is nothing but pent1ene. Correct? And this is pent1ene. Now we know that whether this is the most substituted one. No. How you say whether it is most substituted or not? Let's just look at the carbon-carbon double bond. So if you see here, you can see in one carbon there are 2 hydrogen atoms are there, and in the other carbon you have 1 hydrogen, and the next one is, you can see CH2, CH2, CH3 is present. So I can say in this alkene 3 hydrogens are present as intact, only 1 hydrogen is replaced. That means 1 substitution has happened. So I can say this is not the most substituted. But if you are doing the elimination from beta 2, then what you will get, CH3, then CH, double bond CH, then you have CH2, CH3. Now if you are looking its structure, how it is looking like, you have 1 more hydrogen here. I am replacing this. 1 more hydrogen is getting replaced with the CH3. Then you have CH, double bond CH. Then you have CH2, CH3 is coming here. Okay, here CH2, CH3 is present. CH2, CH3 is present. Now you can see it is substituted twice. 2 hydrogen atoms are replaced with the 2 groups. So I can say the most substituted is pent-2-ene. So we have learned that during elimination, if the product formed is most substituted, then that will be based on Seitzeff's rule. If least substituted is the product formed, then that is based on which rule? Hofmann's rule. Okay, now in this question you can see very clearly they are telling pent-2-ene is formed, and we know that pent-2-ene is the most substituted one. So it is following which rule? I can say the answer here is Seitzeff's rule. Option 3 is the correct answer. I hope all of you are getting this one, option 3. So I am sure these type of questions we have done in plenty. So I hope Brainiac students, they have done it very clearly and they will be getting it right. Okay. So we have our repeaters batch started. So any one of you who have a right attitude or a passion to become a doctor, we are there to help you, to make you a doctor, or to make you understand the subject, to enjoy the subject. We are there for you. Okay, so let's go to the question. Which one among the following is the correct option for the right relationship between Cp and Cv? And we know that this is a question from nothing but our thermodynamics. So they are asking for 1 mole of an ideal gas. So we know that for n mole of an ideal gas, Cp minus Cv is equal to Nr. Correct? This is for n mole. Okay, this is for n mole. Now for 1 mole, what we need to do? Put n is equal to 1. If put n is equal to 1, this will become Cp minus Cv is equal to R. So this will be the correct answer. So it's a very easy question. All these questions with the minimal knowledge you can do it. So the answer here is option 4 is the correct answer. Okay, I hope all of you have made it right. Okay, so let's go to the next question. Again, it's a question from organic chemistry. So let's try to do that. So again, one more thing I am telling, don't worry, NEET is not the last option, don't worry. But again, I am telling, if you have a passion to become a doctor, okay, please follow that, because if you are enrolling to the job that you have liked the most, because every day will be a fruitful for you. So I am urging, don't think like 1 year is going or nothing will happen, sir. Nothing will happen, because years will go by. The only thing is whether you have attained your dreams or not. So that's why I will encourage all the students, if you have a passion to become a doctor, you please study. It's completely the NCERT, nothing else. So we are here to help you. You can just approach us, don't worry about it. Okay, so let's go to the next question. What is the IUPAC name of the organic compound, okay, formed in the following reaction? So it's a very easy question, again from aldehydes and ketones. So they have given acetone as the starting product. Okay, so we know acetone is nothing but CH3, C double bond O, CH3, correct? Now they are telling this is being treated with what actually? We know C2H5MgBr. We know it's a Grignard reagent. Correct. C2H5MgBr. How you know that it's a Grignard reagent? Because it has the formula RMgX. So it's a Grignard reagent. Now we know that during this reaction, or every aldehydes or ketone have the carbonyl group which is polar in nature. So if it is polar, means it will always present in the medium like this. The oxygen which is electronegative, it will attract the pi bond towards it and it will become O minus, and you will have a plus charge present like this. Now we know that in the medium, this alkyl magnesium halide or Grignard reagent will split in such a way that we know that magnesium is highly electropositive. So when this bond breaks, the C2H5 will acquire negative charge, and since magnesium is electropositive, it will become positive charge. Now we know that here oxygen has negative charge. So if you look at oxygen, it already have 2 lone pair, correct? So there is 2 electrons here and there is a negative charge, 8 electrons in oxygen. So its octet is complete. But carbon, if you are looking, there is only 6 electrons around the carbon. So surely the first attack will be from the nucleophile, who will come and attack this positive charged carbon, and you will get a the first thing like this, CH3, then you have carbon, then you have C2H5 connected here, and you have CH3 here, and next step O minus is there, so minus will attract the positive MgX and you will get something like this. But the reaction is not stopping here, because they are telling the next step they are also hydrolyzing it. So hydrolyzing means what will happen here? We know that on hydrolyzing this compound, there will be lot of H plus and OH minus present in the medium. And I know that OH minus is a strong nucleophile. So it will easily attract the highly electropositive magnesium that is present here. So it will immediately form MgOHX. So what is remaining? We know that there will be CH3, carbon, then there is a CH3. So C2H5 I am splitting and writing like this, CH2 and CH3, and you have O minus is remaining. So to this O minus, who will come and attack? The H plus will come and attack, and finally the product you are obtaining here. So the product you are obtaining here will be which one? CH3, then C, CH3, then you have CH2, CH3, then you have OH. So this is the final product. So what can be the name of this product? Can you tell me? So I will choose the longest possible chain. So let me say this is my longest possible chain I have chosen. Now if I am numbering it, I know this is the best minimal way of numbering to get minimum number to the alcohol like this. I hope it is clear for you, right? Now tell me what is the name of this compound. Parent chain has 4 carbon atoms, and second question you have methyl and alcohol. So I can name it like 2. Okay, I'll put another color so that it is easy for you to understand. So I can say 2-methyl. Okay, parent chain has 4 carbon atoms, so we say but, and they are linked through single bond, so we say butane. And at the second position you have ol, so butane 2-ol. So the answer is 2-methyl butane 2-ol. So this is present, 2-methyl butane 2-ol is present as option 2. So my option 2 is the correct answer. I hope all of you have got this, because again this is directly from NCERT, and we have practiced it a lot of times. Even in our model exam this type of questions were there. So I hope all Brainiac students might have scored completely until this question. All of you have scored perfectly. Okay, so let's go to the next question. This is from the chapter Ionic Equilibrium. The question here is the pKb of dimethylamine. So they have given the pKb of dimethylamine and pKa of acetic acid at a temperature T Kelvin. The correct option for the pH of dimethyl ammonium acetate solution is. So we know that they have given pKb. Okay, they have given the pKb value of which one? They have given the pKb value of dimethylamine. Okay, so dimethyl CH3 twice NH, dimethylamine, and its value they have given as what? Actually they have given it as 3.27. okay, then the next one they have given the pKa of which one? They have given the pKa of another compound, that is acetic acid. We know acetic acid is nothing but CH3COOH. So its pKa value they are giving it as how much? 4.77. okay, now we know that dimethylamine, it's a weak base and acetic acid is a weak acid. So if these two are combining, you will get a salt. Okay, salt formation will happen, and for that salt we know that what is the salt that is formed here? Dimethyl ammonium acetate. Okay, dimethyl ammonium, okay, ammonium acetate, dimethyl ammonium acetate. This is, so they are asking what is the pH of this particular compound. This is what they are asking. So we know that pH of such a salt for weak acid versus weak base. We have learned this. We have a table in our material. So 7 plus, what is the formula? So we have 7 plus half. Please remember pK, okay, pKa minus pKb. This is the formula. This is directly given in our material. So you know that 7 plus half of, what is the pKa value here for acetic acid? They have given it as 4.77, and for pKb this is given as 3.27. so if you are doing this, you will get half of, what is this value? If you are subtracting it, we can easily say this is 1.5. So 1.5, half of 1.5, we know that that is 0.75, correct? 3 by 4. So the answer here is 7.75. Direct question. So the answer here they have clearly given the answer as option 1 is the correct answer. I hope it is clear for you. All of you have done it perfectly, I hope. Now again we have a question from which chapter? Chemistry in Everyday Life. So they have given you two statements. Given below are two statements. First statement is aspirin and paracetamol, they belong to the class of narcotic analgesics. Okay, just to think logically, if it is a narcotic, will then the medical shops owners can sell this aspirin and paracetamol? Surely not. So we can say, we know that aspirin and paracetamol are what actually? They are non-narcotic analgesics. We have learned this classification. Okay, again this is directly a question from NCERT. Okay, so we have learned it during our theory class also. And next one you can see statement 2, morphine and heroin are non-narcotic analgesics. That is also wrong. We know that they are narcotic analgesics. Suppose you think if morphine and heroin are non-narcotic, then you can easily sell in your medical shops, right? Is it possible? No, you will be entering into jail. You know that. Okay, so I can say both statement 1 as well as statement 2 are wrong. So which is that option? Both statement 1 and statement 2 are wrong. Yeah, option 4 looks the correct answer. Both statement 1 and statement 2 are false. Correct? Now let's go to the next question. Yes, we have a next question. I hope this is from the chapter redox reaction. Which of the following reaction is a metal displacement reaction? Choose the right option. This is what the question is about. Okay, now we know that metal displacement reaction. So here a metal will be displaced during the course of the reaction. So if you look at the first option, you can easily see that iron is reacting with the HCl. And here we know that iron chloride is formed and hydrogen is displaced. Metal is not displaced here. It is liberating hydrogen. So first one is not the correct answer. Next one, they have given a decomposition reaction, PbNO3 twice, PbO and 4NO2. So we know that this first one is a redox reaction where the oxidation state of iron is changing. Initially it was 0, now it is changing to +2 state. Correct? So the oxidation number is increasing. And now if we are looking at the oxidation state of hydrogen, if you see X -1, so +1 oxidation state was there and moving to 0. So the oxidation number is decreasing, so reduction is happening. So this is nothing but a redox reaction. But they are asking metal displacement reaction. Second one, it's a clear case of decomposition reaction. Decomposition reaction. Okay, so the second one is a clear case of decomposition reaction. Okay, so you can see here lead nitrate is getting decomposed to lead oxide and NO2 and O2. So if you look at the third one also, you can see it is KClO3 that is on heating, it is getting decomposed. So it is also a clear case of decomposition reaction. So I can easily say from these three options are not the correct answer. So surely the answer will be option 4 will be the correct answer. But just analyze this one. So here you can see Cr2O3 on reacting with aluminum. So it is displacing the metal. Aluminum is entering here, Al2O3 and displacing the chromium metal. So I can say it's a clear case of metal displacement reaction. Metal displacement reaction. Correct? So option 4 is the correct answer. It's an easy question. We have this reaction many places in our NCERT textbook. So direct question for you. So coming to the next question, this is from the chapter biomolecules. The RBC deficiency is a deficiency disease of this. We are even learning in our biology chapter. So we know that RBC, red blood cell deficiency, is just because of vitamin B12. So that is option 3 is the correct answer. Okay. So we have the next question in front of you. You can see the molar conductance of NaCl, HCl and CH3COONa at infinite dilution. They have given it as. So this is from the chapter electrochemistry 126.45, 426.16 and 91.0. Okay, the molar conductance of CH3COOH at infinite dilution. I can say this type of question even +2 students will know. This is clearly solved in NCERT example questions. You can easily say there. So I will tell you the method how to do this one. They are telling the molar conductance of NaCl. So let's split it up and write it up. So we can say for NaCl, the molar conductance, let's say we can say Na plus and Cl minus. This is how we are making this one. Okay, so let's say yeah, so I can write it like this, Cl minus. You might be knowing it, and let us assume for this one, okay, I will say this in a plus sign like this. So we know, let's assume this is X and this is Y. Okay, now they are telling for HCl, so lambda of HCl, I can split it like what, lambda of H plus and you have lambda of Cl minus. Okay, so here this one I can say this is Z. Okay, here Cl minus is there, that I will take it as Y itself. Now next one we can say they have given the molar conductance of CH3COONa. So how this will split it up? So we know that this can be splitted like lambda of CH3COO minus, okay, and lambda of Na plus. So Na plus we already assigned X, and this one I can assign W. So this is the final thing. Now let's write this in quadratic form. So we know that molar conductance of NaCl is given as 126.45. So I can say X plus Y is equal to how much? 126.45. Correct? This is X, this is Y. On adding this, we are getting the molar conductance as 126.45. Next one, HCl, they have given as 426.16. That is nothing but Z plus Y. So I can write Z plus Y is equal to how much? They have given that value as 426.16. So I can write that 426.16. Now third one they have given for sodium acetate, it is given as 91 Siemens square. So sodium acetate, you can split it like W plus X. So W plus X, the value is how much? They have given, let's write it up. So it is given as how much? 91 Siemens square. So you have got 3 equations. Now what you need to find it out? You need to find out the molar conductance of acetic acid. So let's write it up. Molar conductance of CH3COOH. So how I can split it up? So I can say CH3COO minus, correct? So molar conductance of acetate ion, CH3COO minus, plus the molar conductance of H plus. Correct? So acetate ion we have already assigned the value as W. Correct? So W we need to find out. Then H plus we have assigned the value Z. So indirectly they are asking you what is W plus Z. So we need to find out what is W plus Z. This is what they are asking. Now how we can find out from this one, W plus Z? So let me number this one. This is equation 1 and this is equation 2 and this is equation 3. Now if I am adding or if I am subtracting 2 from 1, first step I am doing is subtracting 2 from 1. So what I will get, if I am subtracting 2 from 1, Y and Y will cancel off and you will get Z minus X. Z minus X, if you are doing here, you can easily see this will become how much? Around 300, right? 300, I am approximating it for my calculation purpose because 426 minus 126 is nothing but 300. Now after getting this equation, I am making this equation as fourth one. Now I am going to do 4 plus 3. So next step I am doing is 4 plus 3 I am doing. So if I am doing 4 plus 3, what you will get? So 4 plus 3 if I am doing, you know that both one have plus X and other have minus X. Both of them will get cancelled and you will get W plus Z, and that is what you needed also. So W plus Z means how much? 300 plus 91. So I can say it will become 391. So my answer is W plus Z is what I have needed and that is what I am getting. So that is 391 I am getting. So here the answer is approximately 391. So any option like that? Okay, the answer is 390.71. So we have done some approximation. So the correct answer here is option 4 is the correct answer. So I hope you understood how to do this one. So let's go to the next question. So the next question is from the chapter chemical bonding. So you are given different structures and they are asking you what is the shape of it. So the first one is PCl5. So PCl5, we know we have phosphorus atom. Okay, phosphorus group 5. So we have chlorine atom that is present like this, Cl, and you have Cl like this and Cl, and you have two chlorine atoms like this. Correct? So what is the hybridization? We know that this is what is the hybridization, it will come. So we have okay, even with hybridization you can find it out, but looking at the shape I can easily say this is nothing but what is the shape of this compound. So PCl5 is there. Okay, so we have trigonal, okay, biopyramidal. Okay, so A4 will be matching. Okay, A4. Now we know that SF6, we have seen this structure many a times, and we know that with the by-heartedly we know. So SF6, something like this, you have sulfur atom, okay, and you have fluorine atom present like this on the 4 parts, and all these are we have learned in the chapter P block elements as well as in chemical bonding. So this is nothing but octahedral, correct? Octahedral. So we can say SF6 is octahedral. So let's look at the options. So A4 is present in 2, okay, and SF6 is octahedral, that is also present in the same thing. Now next one, BRF5. BRF5 is a structure. Okay, BF3 we can easily say. BF3 is which one? Trigonal planar. So we can say D is 2. D is 2 in option 3. So I can say third one is the correct answer. And C, BRF5 have square pyramidal structure. Okay, all these things, how to calculate this, all these things we are learning in the chapter chemical bonding. We will find out the hybridization and we will see the shape, what it is. I hope it is clear for you. Okay, BF3 is it's trigonal planar. So its hybridization is sp2bf3. We know that Bf, okay, and one more fluorine atom present like this. So we can see spp, it's sp2 hybridization is present here. Okay, let me draw it for making it clear. Okay, so if you have sp2 hybridization, we know that its shape will be planar, and we know it is having a planar structure. The all things will be lying in same plane. Okay, so that is trigonal, 3 sides, so trigonal planar. Now let's look at the next question. Which one of the following polymers is prepared by addition polymerization? So we know that this is from the chapter polymers. So we have different types of compounds given. The first one, novolac, we know this is formed as a product of condensation polymerization. So it's a condensation polymer product. Dacron, another one which is formed out of condensation polymerization. As an example, we are learning. Now next one, Teflon. Teflon, we know it is formed as a part of addition polymerization. So my answer for this question is option 3. So what is a compound that is getting added here? We know that CF2 double bond CF2. This is undergoing polymerization in such a way that you have CF2 units are getting undergoing n number of polymeric chains are combining, and you are getting tetrafluoroethene. Okay, that is the compound here that is undergoing addition polymerization and forming Teflon. Okay, so I hope option 3 is also clear for you. Even nylon 66 is also formed out of condensation polymerization only. Okay, this is also condensation. It will eliminate water. Okay, so let's go to the next question. So the correct option for the number of body-centered unit cells in all 14 types of Brevis lattice unit cells are. So we know that this is from the chapter solid state. In that chapter in NCERT textbook there is a table mentioned. So they are asking in that 14 types of Brevis lattices, which of them have, okay, then body centered unit cells. We know it is 3 in number for 3 people. Okay, we have body centered unit cells. So it's a direct question. So answer is 2. Okay, so rhombic will come into picture, simple cubic will come into picture, orthorhombic. So we have 3 is the correct answer. Okay, Next one, zirconium and hafnium have similar atomic and ionic radii because of, we know that this is from the chapter D and F block elements, and we know what is the reason. If you go through the option itself, you will get it, because we are learning there in huge way. We are understanding it and understanding shielding effect, what is shielding effect and what is lanthanoid contraction. So here nothing more to explain, just I could say the answer here is lanthanoid contraction is the reason why both of them have similar atomic and ionic radii. And the reason for that, shielding, what is the effect of shielding, those things are, everything is explained in our lectures, so you can just, it's a cakewalk. Okay, next question, we have the right option for the statement Tyndall effect is exhibited by. We know this is from the chapter surface chemistry. So Tyndall effect means in the colloidal, we know Tyndall effect is exhibited by whom? Basically colloidal solutions, correct? Colloidal solutions. So we know that it is a splitting of the light on hitting the colloidal particles or bigger particles is called Tyndall effect. So here, if you look at here, glucose, it has a molar mass of 180. It's a small particle. NaCl 53 molar mass. Urea NH2CONH2, that is having 60 as the molar mass. Starch is very big. It's a bigger colloidal particle. So there it will exhibit a Tyndall effect because the particle being very big. So light, when it enters into it, it will split the light. So I can say right option for the Tyndall effect is nothing but starch solution. Option 1 is the correct answer. All these are very, very easy questions. We have done it. Now the next question, it's a very good question. It's a question directly from NCERT, from example question. Only thing is they have removed the Vivid Bharati. That is the only thing they have removed. The rest of the question remains the same. But this question is very dangerous. Why? Because if you see the option 3 and 4, before I am calculating, you can see both of these are very quite similar. So we need to do it in utmost way. So let us read the question. A particular station, All India Radio New Delhi, broadcast a frequency. So they are given the frequency as 1368 kilohertz. Okay, and they are telling the wavelength we need to calculate. So we know that wavelength of the electromagnetic radiation transmitted. We know that the fundamental equation C is equal to nu lambda we need to apply. So what is lambda here? Lambda is nothing but C by nu. So how to calculate this? So lambda is equal to C, we know that is 3 into 10 power 8, and the frequency is 1368 into 10 power 3. So if you do this, you will get an answer something like 219.29 meters. If you do this, you can do this calculation. But please remember, on seeing this, don't jump to the answer 4, because this can be further approximated, because this is 9. So this will be 219.3 meter. This is the perfect answer. So we can say option 3 is the correct answer here. Clear? So it's a good question. All of you might have made a mistake on seeing dot 2. They might have go for answer 4. Okay. This is where you need to be very careful. And I remember during our theories lectures, we were giving special care for how to do the mathematics part of the physical chemistry very fast and how to do it accurately. And I hope I have explained all these phenomena. Okay. So let's go to the next question. So an organic compound, it contains 78% carbon and remaining percentage hydrogen. So I can say the compound has carbon 78% and the remaining hydrogen means it is 22%. So this is from the chapter Basic Concepts of Organic Chemistry and how to find the empirical formula for this one. So we will take first the percentage and we will divide by atomic mass. Here also we will divide by atomic mass. On dividing this one, so what you will get? We know that 12 into 6 is 72. So you will get 6.3 approximately. This is 22. But this is not a proper fraction. So what we need to do? So we will, to make it minimal number, we will divide by 6.3 again on both sides. So what will become 22 by 6.3? So this will become 1 and this will become 3.3. Now how I can say the, if I can round it like CH3, this will be, it will not be CH4. The reason for that is if I am multiplying by 3 on both sides, you will get C3. Okay, this is 3 into 3 9, so it will become C3 H9. You will get it as properly. Okay, so I can say CH3 will be the correct answer for this one. It is not CH4. Don't approximate this to CH4. Or even you can use the logic. If it is more than 0.5, you can approximate it to 4. It is less than 5, so we can say CH3. So the answer here is CH3, that is option 1 is the correct answer. So let's go to the next question. It's from chemical kinetics. Go through the question. For a reaction A to B, okay, for a reaction A to B, okay, so they are telling the enthalpy of the reaction delta H, or the enthalpy, they are giving it as negative. So that is minus 4.2 kilojoule per mole. So if it is negative, means I can easily understand it is an exothermic reaction. So delta H is negative. So if you do, we know that if it is an exothermic reaction, what will happen? Heat will be liberated during the reaction. So heat is liberated means what is happening? Energy is going out. Energy is going out means the product you are obtaining, is more stable. It's a stable product with the energy is getting released. So I can say that if you comparing A and B, this will be more stable since it is releasing the energy. So I can say that its energy will be very low. So if I am looking at the options, I can say in the first one, both A and B are having similar energy. So that is not the correct answer. Option 2, if I am checking, A is having lower energy and B is having a higher energy. But we know that it is exothermic and liberating heat or energy. So B should be having lower energy. But if I am looking at option 3, there also B is having higher energy. So only option 4 says that B is having a lower energy, because this is potential energy on the left side. So this is less for B, and A is having higher energy. So it is forming more stable product. Okay, so I can say option 4 is the correct answer. Clear? So let's go to the next question. Very good question. This is from the chapter haloalkanes and haloarenes. So the correct sequence of bond enthalpy of CX bond is. So please remember, here they are asking bond enthalpy. It is not dipole moment. Okay, bond enthalpy. Bond enthalpy means energy which is required to break the bond. And we know that when the size of the bond length or the bond length is very less, then the bond enthalpy will be very high. So here they have compared different carbon halogen bonds. So they have given CF bond, then you have C chlorine bond, C Br bond, and C iodine bond. And I know that out of this, the bigger atom is iodine, so its bond length will be very high. If its bond length is very high, then surely its bond energy, you can easily break it. Bond energy will be very less. So here the smaller one is carbon and fluorine, so you need huge amount of energy to break this bond. So its bond energy will be very high, or its bond enthalpy is very high. So I can say that it will follow the order CF first, then CCl, then CBr, and then Ci. This will be the order, because on moving down the group, the size of the atom is increasing and the bond length is increasing and the bond energy is decreasing. This will be the answer. So which one is that? Option 4 will be the correct answer for that one. Option 4. Clear? Now let's go to the next question. Which one of the following methods can be used to obtain a highly pure metal which is liquid at room temperature? This is a good question. This is from, again, we know that we can take it as like basic concepts of organic chemistry or even extraction. So here we know that since it is liquid at room temperature, we know that distillation is one good technique where you can heat it and make the metal as pure as possible. Some students may confuse it with zone refining, but I will say, since it's a metal and since it is liquid at room temperature, the best technique will be distillation, will be my correct answer. Okay, now let's go to the next question. The right option for the number of tetrahedral and octahedral voids in a hexagonal primitive cell. So it's a hexagonal primitive unit cell. So the number of unit cells, we can say it is equal to the number of corner atoms, that is equal to 6. So we know that here number of tetrahedral voids, okay, the number of tetrahedral voids is equal to 2n, and number of octahedral voids, okay, the number of octahedral voids is equal to n. Okay, so if you are looking at it, the answer will be 2n. So n is the number of atoms per unit cell, that is here is equal to 6. So I can say the answer will be 2 into 6, that is equal to 12 tetrahedral voids, and number of octahedral voids is equal to number of atoms in the unit cell, and it is equal to 6. So 12,6, option B should be the correct answer for this one. Clear? Now let's go to the next question. Among the following alkaline earth metal halides. So we know that this is from S block elements, the question. Okay. So one which is covalent and soluble in organic solvent is. So if you're looking at the alkaline earth metal halides, we know beryllium chloride is there. Okay. We will do as per beryllium chloride is there. Then we have down the group magnesium chloride is there. Then we have calcium chloride is there. Then strontium chloride is there. And we know that on moving down the group, what will happen? On moving down the group, ionic nature increases. Covalent nature, what will happen to the covalent nature? It will decrease. So I can easily say here one which is covalent, mostly covalent will be beryllium chloride. This is the most common point we discussed in that chapter. Okay, and this will be soluble in organic solvents since it is covalent in nature. So the answer here will be which one? Beryllium chloride. Option 2 will be the correct answer. Clear? So all directly written in NCERT, nothing more to learn. Okay, the next question is from the chapter hydrogen. So please remember, in this NEET exam, they have touched almost every chapter. Okay, so tritium, it's a radioactive isotope of hydrogen. It emits which of the following particles? We know that reaction. It emits what actually? Beta minus. So the answer, direct question. So the answer is option 3 is the correct answer, beta minus. Okay, beta minus is the correct answer. Okay, so let's go to the next question. Again, the chapter, it's from basic concepts of organic chemistry. So the correct structure of 2,6 dimethyl decphorine. So let's start numbering and we'll get the answer very fast. So first option, if I'm doing, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from this you can understand 2,6 dimethyl is coming, but 10 carbon atoms, so dec is coming, but it is 3 and 4, minimum number is 3. So I can say this is 2,6 dimethyl dec 3 in. So this is not the correct answer. Look at how intelligently they have kept the first option. Now similar to this one, we only need to change this bond from this position to this position, that is present in option 3. Now we will number it 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here if you see 2,6 again dimethyl, okay, dimethyl, 10 carbon atoms are there, so dec, and between 4 and 5 minimum number is 4, so we say it is decphorine. So I can say the correct answer is option 3 is the correct answer. I hope it is clear for you. Now let's go to the next question. Go through the question. BF3 is planar and electron deficient compound. We know already BF3, correct? We have seen in one of the match the following. So again, they are just asking you the hybridization and the number of electrons around the central atom. Since we already drawn that, I can easily say this is boron, this is fluorine, and we can draw the planar structure of boron trifluoride. And if you see here, we know it's electron deficient. Why? Because there are only 6 electrons around the boron atom. So from that itself, I could understand. If you see the hybridization, yes, this is P and this is P. So the hybridization here is sp2. And around the central atom, if you see how many electrons are present, 2, 4, 6. 6 electrons are present. So the answer here is sp2 hybridization and 6 electrons around the central atom. Option 1 is the correct answer. Clear? Very easy question. Now let's go to the next question. It's from the chapter states of matter. It's from states of matter. Correct. States of matter. Every chapter you can expect question. It is evenly distributed. So don't think like some people are telling, sir, this chapter is important and that chapter is important. I will not recommend. It's every chapter. But the thing is, if you learn every chapter, but please learn from NCERT and get a good guidance from Brainiacs classes, you can easily score. I can guarantee you more than 42, more than 43 questions. 2 questions I will always give an option because it can be anything, you may make a mistake, but more than 43 is guaranteed. Okay, just look at the question. Choose the correct option for the graphical representation of Boyle's law, which shows a graph of pressure versus volume at a different temperature. So we know that pressure versus volume. So Boyle's law means it's between pressure and volume, and we know that it is inversely, pressure is inversely proportional to volume at a constant temperature. This is what Boyle's law states about. So, and how is the graph look like? You might have learned this in many places in NCERT, very clearly written. Okay, so Boyle's law graph between pressure and volume, the basic nature of the graph is like this, hyperbola. Now we know that from the options only 3 and 2 looks like that, only 3 and 2. Now from this one, how to identify? So they are given, the first graph is at 200 Kelvin, then 400 Kelvin and 600 Kelvin here. But here they are telling it is at 600 Kelvin, this is 400 Kelvin and this is 200 Kelvin. So how to do this? I will tell you a shortcut. Even this one, this is same question, similar question is present in our theory stuff. So all the Brainiac students might be knowing it, how to do this. So I will tell two methods. First, let me tell the first method. Here, what you can do here is you can make any of these things as a constant. For example, I am taking volume constant. So volume constant means I will take any point here and I will draw a straight line. Okay. So I can say the point which is interfering at this point. At this point the volume is this one. So let's say this is 1 liter. So this is 1 liter. At this point also it is 1 liter. At this point also it is 1 liter. Now volume is fixed. But you can see if I am drawing to the pressure side, you can see here P1 is coming. Okay. And if I am extending this one to here, you can see here P2 is coming. Okay. And here you can see if it is extending, P3 is coming. Now we know that on the left side, on moving up, the pressure is increasing. So tell me there the relation, we can say that P3 is greater than P2 greater than P1. We know that on seeing the graph. And we know that when volume is fixed, how pressure is related to temperature. We know that pressure is directly proportional to temperature. So that means if the pressure is high, temperature is high. So here the pressure is P3 is higher. Then I can say similar to that, temperature T3 should be higher and T2 should be higher and T1 should be higher. So here which is T3? 600 Kelvin. So we know that 600 Kelvin is greater than 400 and which is greater than 200. So surely T3 should be higher, but in this graph, third one, T3, that is here. I can draw it here. This is T3. This graph is T3. So T3 is 200 Kelvin, which is lesser value. So in this graph, it is oppositely, it is following T3, T2, T1. So this is a wrong one. So my answer is option 2 is the correct answer. So many students will ask a doubt here, sir, why you are fixing volume as a constant here? I am telling you don't want to fix the volume here. You can even fix here pressure as a constant. If the pressure is constant, then volume will be varying. Then what we need to do? We know that V3 will be greater, V2 will be lesser, V1 will be lesser. So how volume and temperature are related? Volume is directly proportional to temperature. So there also we could understand T3 will be higher, that is 600 Kelvin. So that also correct. We say option 2 is the correct answer. I hope the concept is clear for you. Okay. Now let's go to the next question. The dihedral angle of the least stable conformer of ethane is. Very, very easy question. We know that ethane will show conformation and NCERT clearly explains that CH3 is single bond CH3. So how will you draw the conformation of ethane? So you might be knowing it. You will put hydrogen here, here also hydrogen, and here also hydrogen. So this is the projected carbon, and on the back side you have another. I can draw. Okay, we'll take another color. You have hydrogen here. Okay, hydrogen here, and here also you have hydrogen like this, and here also you have hydrogen like this. And we know that this is called completely eclipsed form. Completely eclipsed. And we know that if you look at the stability order, you might have learned in our theory class, stability order is which one? Who is more stable? We know that most stable will be always staggered one. Okay. Then who will come? Then we have Gaussian form. Then who will come? Then only eclipsed form will come. So here in this question they are asking the dihedral angle of least stable. So least stable is eclipsed one. We know that. So I have drawn the least stable structure, and they are asking the dihedral angle. Dihedral angle means the angle between this hydrogen and this hydrogen, this hydrogen and this hydrogen. We know that one is behind the other one, one is behind the other one, so the angle is 0 degree. So we can say that the answer here is 0 degree. Clear? It's a very easy question. Okay, Now we'll go to the next question. Again, this question is from, I can say this we are learning in many chapters. Okay, acidic strength concept is based on acidic strength. So they are telling acidic strength increases in the order given as HF, HCl, HBr, HI. So how we will analyze this? So we know that to check the acidic strength HF, what we need to do? We will liberate the H plus from this one. Then you will get what? F minus. So I can say that if F minus is stable, then it will not attract the H plus back. Okay. Similarly, let me say HCl. Okay. So it will release H plus and you have Cl minus left behind. And similarly, you have HBr. Okay, that will release the H plus and you have the Br minus left behind. And similarly, we have the Hi that will give the H plus and you have I minus left behind. So I can easily say among the anions, the stability order is I minus greater than Br minus, then Cl minus, then F minus. What is the reason for that? They are telling because iodine is a bigger size atom. So when it has a negative charge, it can distribute this negative charge in a bigger space. That's why I minus is most stable. So that is the reason if I minus is most stable, then it can easily release the H plus. It will not attract the H plus back because the remaining species is most stable. So I can say that Hi is the strongest acid here. So I can say the statement 1 is perfectly correct. Now we go to the statement 2. They are telling the same thing. Reason for that, as the size of the elements fluorine, chlorine, bromine increases down the group, the bond strength of HF, HCl, HBr and HI decreases. That is also correct because we know that here HI has much higher bond length. If bond length is very higher, I know that the bond enthalpy is very less. You can easily break the bond. That means it can release the H plus very fast. So I can say statement 2 is the perfect reason for the first statement. So both statement 1 and 2 are completely correct. So that is option 3 is the correct answer. Both statement 1 and 2 are true. Clear? I hope it is clear for you. Let's go to the next question. So the next question is from the chapter solutions. Okay, second year solutions. So the following solutions are prepared by dissolving 10 gram of glucose, okay, glucose C6H12O6 in 250 ml of water and 10 gram of urea in 250 ml of water and 10 gram of sucrose in 250 ml of water. They are asking the right option for the decreasing order of osmotic pressure. So we know the osmotic pressure, the formula pi is equal to CRT. Okay, so C is nothing but our concentration. Concentration is expressed as what? Molarity. Molarity is number of moles per unit volume, R into T. So the number of moles can be further written as weight by molecular mass. So this will come like this. Correct? Now if I am looking into this relation, I can easily say here pi, that is the osmotic pressure, is equal to, here weight in gram is a fixed quantity because in this question all the three compounds are having 10 gram, that is fixed. So this is a constant. Now R is a constant, we know. Okay, all these are done at the same temperature. They are not mentioning different temperatures. So this is also constant, and they are all adding to the same volume, 250 ml. Everything is 250 ml. So I can say volume is also fixed or constant. So only thing that is variable here is which one? The molecular mass. Now tell me how the molecular mass is varying with this osmotic pressure. I can say this is inversely proportional to the molar mass. Okay, now what is the meaning of that? That means that if the molar mass is very high, then the osmotic pressure P will be very low. Now from this compound, the first one is glucose. So glucose has the molar mass, how much? Tell me, 180. Okay, so it is having an osmotic pressure P1. Now next one is which one? Urea. Urea, we know the molar mass very easily, 60, NH2CO, NH2. It is having P2. Now next one is sucrose. So sucrose, if you calculate the molar mass, it is coming around 343 or somewhere there. So anyway, it is higher than glucose, P3. Now tell me which one is having higher molar mass? Sucrose. So its P3 will be very less. So I can say P3 will come last. Then higher, the next lesser molar mass is this one, glucose. So glucose will also have osmotic pressure lesser. So I can say P1, then P2 will come. So from this I could understand the highest osmotic pressure is for urea. Why? Because its molar mass is very less. If the molar mass is very less, osmotic pressure will be very high. So answer is P2 greater than P1 greater than P3. P2, P1, P3. Option 3 is the correct answer. I hope it is clear for you. Okay. So let's go to the next question. So the next one is from the chapter coordination compounds, and it's a very familiar question. Ethylene diamine tetraacetate, EDTA. In our lectures, we are clearly explaining what is EDTA, what is its role and everything. They are asking what is the structure of EDTA. So let's understand the structure of EDTA, how the EDTA looks like. Okay. So we know that there are two CH2 units are there, and there is two donor sites of nitrogen atom is there, and this is connected to ethylene diamine. So we have drawn ethylene and we have diamine also, we drawn tetraacetate. So we know that this is a CH2COO minus, this is CH2 tetraacetate, 4 are there. So this is also, we can see OO minus, and there is a CH2, and you have OOCH2 like this. So if you see number of donor sites, this is one donor site, second one, third one, and fourth one, there is 2 nitrogen atoms. So totally 6 donor sites are there. So it's a hexadentate ligand. So if you look at the options, you can see ethylene diamine tetraacetate ionis. I know it is a hexadentate ligand, hexadentate. So option 3 with 4 oxygen atoms and 2 nitrogen donor atoms. Option 3 is the perfect answer. Clear? Very easy question. Now let's go to the next question. The incorrect statement among the following is, this is a good question. Why I will tell, because they have taken the lines of NCERT as such like that, and I have explained this during our model exams. We have a question similar to this in our model exam. Okay, the incorrect statement among the following is lanthanoids are good conductors of heat and electricity. Of course it is a correct statement. Why? Because we know that lanthanoids and actinoids, they have free electron d orbitals and f orbitals are there, f orbitals are there, so they can easily enter, free electrons are there, it can be good conductors of heat and electricity. Actinoids are highly reactive metals when finely divided. Correct, because on fine division they have increased surface area, so they can be highly reactive. This is also a true statement. Actinoid contraction is greater for element to element than lanthanoid contraction. That is also correct. If you look at the contraction range or how actinoid is contracting with the lanthanoid, we can see actinoid have much higher contraction. Lanthanoids have more effective screening, so the contraction is very less. So I can say actinoids have greater contraction than lanthanoid contraction. That is also correct. Now the last statement, most of the trivalent lanthanoid ions are colorless. I know that in NCERT this is colored. They are changing that term to colorless because we know that lanthanoids have free electrons and vacant d orbitals, so they can easily enter into, or vacant f orbitals, so they can easily enter into colored species. They are mostly colored species in their solid state. So this is the correct answer, because they are asking you the incorrect statement. So this statement is incorrect, but answer is this one. Clear? Now let's go to the chemistry B part. Okay, so we are coming to the question number 86. The question here is the intermediate compound X in the following chemical reaction. So this is from the chapter aldehydes and ketones, and we know this chromyl chloride. On seeing the chromyl chloride itself, you can see what reaction is this one. This is nothing but our Ittard reaction. This is one of the reaction for the preparation of benzaldehyde. Okay, so we know that during the reaction, what is happening? You have toluene is present that will react with the chromyl. Direct question from NCERT. React with the chromyl chloride CrO2Cl2, chromyl chloride, in the presence of carbon disulfide. So this will form a chromium complex. In NCERT they have given that, and I told my dear students to remember. How to remember this one? All of you are remembering. You have CH, then in bracket you expand this one, O, then CrO. Correct? Just if you do this itself, you will get. Then you have hydrogen from here and chlorine from here, so you will get HCl2 twice. This is that chromium complex, and this on hydrolyzing H3O plus, you will get benzaldehyde. So the best way to remember this is chromyl chloride is used. So sure, here also it's a chromium complex. In NCERT they are telling it's a chromium complex. So from the given options, this is the only compound which is having chromium as part of it. There is no chromium here, there is no chromium here, there is no chromium here. So from that itself I could understand option 3 is the correct answer. Clear? Very direct question. So the next question is part of amines. It's a very easy question. So they have given triabromoaniline, and the first reagent used here is NaNO2 and HCl. We know that it will form HNO2. It's a method for diazotization. So this will form benzene diazonium chloride. You can see here. Now they are asking how you can convert the benzene diazonium chloride to benzene. So we know that only here it is converting to the benzene part. N2Cl is getting removed. We know that there are two reagents in NCERT is mentioning that. First one is H3PO2 and the other one is ethanol, C2H5OH. There are two reagents for doing this one to convert the benzene diazonium chloride. Okay, in NCERT it is mentioned like this. If you have benzene diazonium chloride like this present, okay, and if you want to convert this into benzene, what you need to do, you should use two reagents, either H3PO2 you can use, okay, or you can use C2H5OH, ethanol you can use. So in this question they have directly asking what is this reagent. We know that it can be either H3PO2 or ethanol. In this question they have given ethanol. So option 4 is the correct answer. I hope all of you are getting it clear, right? It's very easy question paper this time for chemistry, and everything we have discussed in our theory lectures as well as our revision papers. Okay, so don't worry. I hope all of you are getting very good marks this time for chemistry. Which of the following molecules is non-planar in nature? Okay, non-planar, non-polar in nature. Non-polar means there is no charge in that. So there is no charge means the dipole moment should be equal to 0. So on analyzing this one, I could understand first one is antimony SbCl5. So I know that antimony comes in the same group of phosphorus, so that is PCl5. So both of them should have the same structure. So if you see here, the structure will be looking like this. You have chlorine like this, and you have another chlorine. So it is in one plane, and we know that here the dipole moment, net dipole moment will be 0 here, and you have another chlorine molecule situated like this. And since both of them are in two different directions, so here also dipole moment will cancel each other. So the net dipole moment of this compound is equal to 0. That means this is a non-polar compound. There is no polarity. So I can say option 1 is the correct answer. But if you analyze the other options, you can easily say NO2. We know N double bond O. So there is a polarity difference between this one. So therefore the dipole moment is not equal to 0. And POCl3 also have, if you see the structure, you can see its dipole moment is also not equal to 0. It is also a polar compound. And CH2O, it is nothing but our formaldehyde HCHO. So like this, we know that carbonyl group is polar, so it can be like this, O minus and plus charge and H. So since dipole moment here also not equal to 0. So all these are polar compounds. Clear? So answer is SbCl5. Easy question. Now let's go to the next question from the chapter Atomic Structure. So the question here is, from the following pairs of ions, which one is not an isoelectronic species? So we have learned this many times. Isoelectronic species means what? Isoelectronic means they have the same number of electrons. Here I can easily tell one shortcut. If you see here, manganese, in the option 2 you can see iron and manganese both are in +2 oxidation state. So I know that iron and manganese have different atomic number. If they have different atomic number and both of them are removing the same number of electrons, means surely their number of electrons will be varying. From that itself I can easily say the answer is option 2. Because you know that iron has the atomic number 26 and manganese has the atomic number 25. And if you remove 2 electrons from iron, then it becomes 24 and this will become 23. And if you look at the number of electrons, it will be varying. So that is a simple clue. You don't want even want to count the number of electrons and do it. You can easily do it because iron and manganese have different atomic number and both of them are in +2 means surely they will remove the same number of electrons. So the number of electrons in both will be differing. Correct? Net electrons will be differing. So we can do like that. Okay, here otherwise if you count all of them, here have 10 electrons, and here also if you see manganese 2 electrons are removed means it will have 23, and iron 3 electrons are removed means it will also have 23. But here if you are removing the same number of electrons from both one means iron will have how much? 24, and manganese will have 23. So that is the reason why not an isoelectronic species means option 2 is the correct answer. Now let's go to the next question. This is from the chapter Environmental Chemistry. Okay, very easy question. So let's try to do it. So they are telling first one, SO2 plus O2 giving SO3. We know that this leads to tropospheric pollution. So I can say A is contributing to tropospheric pollution like this. Okay, next one, HOCl on H new light, it is getting to free radicals OH plus and Cl dot, and we know that free radicals will result in ozone depletion. So I can easily say that B is 3, ozone depletion. Now next one, calcium carbonate H2SO4, we know that it will result in acid rain and everything. So we have learned this Taj Mahal and every stuff. So here we can say this is 1. So from this itself, I can easily say the answer. NO2 and NO will result in smoke. So I can say that is this one. So first one, A is 4. A is 4 present only in option 1. So from that itself, I can get the answer. So the answer is first one. Clear? Now next look at this question. So this is from the chapter total pressure they are asking. Again, this is from the chapter states of matter. States of matter. Okay, so you can see from every chapter question is there, and it's a very easy question. Only thing is you need to practice problems. You need to get the right guidance. I can say Brainiacs Classes is one of the best coaching center that is present in Tamil Nadu. That is in Coimbatore. It is situated in Coimbatore, and they are providing you complete online as well as offline lectures. So you can even access from Kerala, Karnataka, even from Andhra. You can get the lectures. You will get the live sessions. It's a regular live sessions are ongoing, and regular test papers and regular question discussion. It is one of the best center where you can get more than 600 marks. So let's look at this question. Choose the correct option for the total pressure, okay, in a mixture of oxygen and hydrogen. So you have oxygen and hydrogen present in a mixture. You have 4 gram of oxygen is present. So number of moles we know 4 divided by 32. So that will be coming around how much? I can say this will be 1/8. And hydrogen, they are telling it is 2 gram of hydrogen. So 2 gram means 2 divided by molar mass, that is 2. So I can say it is around 1. So 1 mole of hydrogen and 1/8 mole of oxygen. So how will you calculate the total pressure here? We can apply the formula P is equal to nRT by V. So what is the total number of moles here? N total will be equal to how much? I can say 1/8 plus 1. That is nothing but I can say that is 9/8. I can substitute here. So pressure will be equal to how much it will be coming? Tell me. So 9/8 into R. R is nothing but 0.082 into what is the temperature? 273 Kelvin, 0 degree. And divided by volume, they are mentioning it is 1 liter, and we have learned in our previous classes 0.082 into 273, that will come around 22.4. So if you do this, how will you get the answer? So I can say this 9/8 is almost 1 point something, so 22.4 into 1 point something will come. So you can do the calculation. So this will become 4, this will become 11.2. okay, and how much you can do it here? So if you do it, you can correctly do it, this one. Okay, so you have 2 options nearby, that 25.18 and 26.02. So I will prefer doing this perfectly, then you will get the answer very fast. So 11.2 into 9 means it is 18. Okay, then 99.8 it will come, correct? 9 into 2, 18 it will come. So how can you do that? So okay, let me do that. 11.29, so you have 18, 1, so 9, you will get 10, so 9, then 10, so it's 100.8 it will come, correct? So let's do that. 100.8. So you will put it here 100.8, or we will take it as 101, that is also fine. Okay, so 101 divided by 4. So if you do it, I can say 4 into 2, 8, again 2 is coming, 4 into 5, 20, then from this itself I could understand it is coming around 25. So my answer will be going for option 1 will be the correct answer, 25.18. Okay, I hope all of you are getting this answer. Now let's go to the next question. So we have now reached up to question number 91, and I hope all of you are doing very well until now. Okay, so up to this one, I hope all of you have made it correct. So I'm happy that all students of Brainiacs classes, they have done extremely well for this particular exam, and we are expecting all marks above 600. And I'm giving advanced congrats for all of you. Okay, so many of the students have called me and they are very happy to share that the coaching has helped them a lot to adjust the time, and I have also told them the different strategies. Suppose if the physics question is lengthy, what to do. So after attempting one or two questions, switch to chemistry and biology, complete it and come back to physics. So all these strategies have worked out very well for our students. Thank you students for doing it in a perfect way. Now let's go to the next question. It's a cakewalk question again from the chapter hydrocarbons. So we can see here they have given sodium. Okay, sodium. Okay, it's a component. It's a question from sodium propanate. So you can see here soda lime decarboxylation is the technique. So they have given NaOH. So lime needs to be there. So what is that lime that should be present here? Calcium oxide. Direct question, and we know that elimination reaction will happen. Na2CO3 will be eliminated and you will get an alkane as part of this reaction. Correct. So it's a direct question. So the answer is calcium oxide. And you remember what is dibalH, diisobutyl aluminum hydride. All these things we are learning in aldehydes and ketones. Nothing to do here. Diborane, red phosphorus. We know red phosphorus is used in HVZ reactions. Correct. Here it's a direct question. Soda lime decarboxylation. And here soda NaOH is present here, and calcium oxide we need to be present along with this one for this decarboxylation to happen. Clear? Now again we have a next question that is almost from the chapter electrochemistry. So how to do this question? All of you read it out. The molar conductivity of 0.007 molar acetic acid is given as 20 Siemens centimeter square mole raised to 1. What is the dissociation constant alpha of the acetic acid? So we know that alpha can be calculated as Ka is equal to C alpha square. We are learning that. Are you remembering the equation? So Ka is equal to C alpha square by 1 minus alpha is there, but we can neglect this because the alpha value will be totally less here. So we can neglect this one. So we can say Ka is equal to C alpha square. We can take it up. Now, so how you can now find out alpha here? So the alpha here can be found out like this. So we know that alpha can be of this compound can be found out by the concentration. Okay, they have given the molar conductivity at a particular concentration. So we will divide the molar conductivity at a particular concentration divided by molar conductivity at infinite dilution. So for calculating that, they have given the lambda 0 of both these ions. So if you add these two, we will get the molar conductivity of acetic acid at infinite dilution. So 350 plus 50, it will become 400. So the alpha value here is, I can say it will become 1 by 20. So now we know the alpha value. Now we also know the concentration. What is the concentration given here? 0.007. So let us substitute here. Now Ka, the dissociation constant Ka for the acetic acid will be, it's a weak acid. That's why we are applying Ostwald's dilution law. So C here is 7 into 10 power minus 3. 0.007 can be written as what? 7 into 10 power minus 3. Now here what I can do, alpha is given as 1 by 20. So I can say 1 by 20 the whole square. Okay, so if you do this calculation, so what is the value you are going to get? If you do this, you will get 1.75 into 10 power minus 5. So mole per liter. So option 1 will be the correct answer here. You can easily do this. 1 by 20 square is 1 by 400, right? So you have 7 by 4 is there, and 100 will come in the numerator, 10 power minus 5 will come. So 7 by 4 is nothing but 1.75. From this itself, you will get the answer. Clear? So I hope all of you are happy until now. We have the question number 94 for you. The slope of Arrhenius plot. Okay, ln(k) versus 1 by t. Hope you are remembering this plot. We are learning this in the chapter chemical kinetics. Okay. So you have the ln(k) versus 1 by t graph. That will be something with a negative slope like this. So what is this slope value? Are you remembering? That is Ea by R. I have taught you this and I asked you to remember the slope. that will be negative. So they are asking this slope value is minus 5 into 10 power 3. They are asking what is the value of EA. Very easy question, because we know the slope, that is minus EA by R, and that slope value they have given it as minus 5 into 10 power 3. So we can cancel this one, and they are asking you to calculate EA. EA is equal to 5 into 10 power 3 into R. R value they have given as 8.314 joule per Kelvin per mole. So if you do this calculation, what is the value you are getting? 5 into 840 into 10 power 3 means 40 kilojoule, somewhere around 40 kilo. You will get the answer option 3, that you will get 41.5 kilojoule. You don't want even to calculate it. Very easy question. Okay, direct question. This is in our theory lectures. As an example question, I am teaching you the same question. Okay, so it's all cakewalk. Now, next question is from the chapter thermodynamics. I was expecting a question from thermodynamics. So they are telling, for an irreversible expansion of an ideal gas under isothermal condition. Since it is isothermal condition, I can easily say delta U will be equal to 0. And since it is irreversible expansion, we know that entropy will be always positive in nature. Or I can say delta S will not be equal to 0. So what is that condition? Delta U equal to 0 and delta S total will not be equal to 0. So we can say option 1 seems to be the correct answer, because in option 1 you can see delta U is equal to 0 because it's an isothermal condition, temperature remaining constant, internal energy change will be equal to 0. Entropy of the universe is always increasing, we know that. So delta S total will not be equal to 0. It's an irreversible expansion. Correct. So I hope it is clear for you. Let's switch to the next question. So the next question, it is also from the chapter. Can you tell me? From the chapter solutions. So we can do that. The correct option for the value of the vapor pressure of a solution at 45 degrees Celsius with benzene to obtain molar ratio is given as 3:2. So we know that to find the total pressure here, how to apply the formula? P is equal to P0A XA plus P0B XB. We have learned this formula many a times. So here P0 is the vapor pressure of the pure solvent. Here A is benzene, that they have given it as 280. And how to find the mole fraction XA? Tell me. XA mole fraction will be number of moles of A divided by total number of moles, Na plus Nb. So here A is nothing but benzene, and they have given 3:2. So this will be 3 divided by 3 plus 2, and you will get 3 by 5. And similarly XB will be equal to what? I can say 2 divided by 3 plus 2, and that will be 2 by 5. So I can substitute that here, 280 into 3 by 5 plus P0B, they have given it as 420. So 420 into 2 by 5. So if you are doing this calculation correctly, so what you will get as the answer? You will get 336 as the answer, 336 mm of mercury. So I can say option 1 is the correct answer here. It's a direct question, just you need to substitute it. Okay, that's it. So we have the next question. Again, the question is from the chapter coordination chemistry. So here they are testing you with, you need to calculate the magnetic moment, and we know that the magnetic moment mu is calculated as square root of n into n plus 2 after finding out the number of free electrons. So the first one, they have given FeCN6, okay, thrice 3 minus. So we know that x minus 6 is equal to minus 3. Cyanide minus 1, so x is equal to in plus 3. So I can say that iron is in plus 3 oxidation state here. So iron is in plus 3 oxidation state means if you look at the number of free electrons here, I can say here cyanide is a strong ligand. So what will happen? The 5 free electrons present over here will get paired up in the presence of strong ligand cyanide. And you will have paired electrons present like this, and you will only have 1 free electron present here. Okay, like this, 1 free electron will be present here. So if I substitute here square root of 1 into 1 plus 2, so you will get square root of 2, that is nothing but 1.73 Bohr magneton. So I can say the first one, the answer is nothing but 1.73, 1 option 4. So we have 2 options like that. Now let's calculate the next one, FeH2O6. So if you see here iron, there is also in, we know that H2O is a weak ligand, so there is no pairing of electrons will happen. There also iron is in +3 oxidation state, and we know that, so in that case iron will have 5 free electrons present like this, because there is no pairing happening there. So 5 free electrons means what is the value you are going to get? So we get the magnetic moment root of 5 n into n plus 2, 5 plus 2 here. So you will get 5 into 7 root of 35, I can say somewhere around 5.73 Bohr magneton. So the second one I will get the answer something like that. So 5.92 or 5.73. So we say second one. B is 1. So B is 1 in option 2. So if you are getting these two correctly, I don't want to look at the other things. So I can say option 2 is the correct answer. So I hope all of you are getting this. Okay. Very easy question. Just you need to do it. Just, you know, basics of coordination chemistry. You can easily get this one. Okay. Now we have again a good question. This is the same question I have even told to my long-term students. That's why I'm very happy about this one. This question asks about, they are introducing a reaction where they are introducing you sodium borohydride. I have told you in my theory class that every aldehydes or every ketones, okay, it can be easily reduced by any reducing agent like sodium borohydride, or even lithium aluminum hydride, or even nickel hydrogen, like that. But if you have an acid, okay, or an ester or its acid derivatives, then it can be reduced only by lithium aluminum hydride. No one else can do the reduction of this one. So in this question, if you see here, you can easily understand that this is an ester, COOR, and sodium borohydride is there. I can easily say sodium borohydride does not have any effect on the ester. Only if they have given lithium aluminum hydride, then I can say it do have an impact. So I can say this part will remain intact in the compound, I mean in the product. It will not change because you have taken what? Sodium borohydride. So just to see the option where this is present similar to this one. And we know this is ketone. So this will be oxidized to what? We know that aldehyde will be oxidized to 1 degree alcohol, and ketone will be oxidized to 2 degree alcohol. Correct? So here ketone is present, so this will be oxidized to 2 degree alcohol, and this will remain as such. That is present only in option 2 where it is remaining like that. In all other options you can see this is getting reduced. So that is option 2 is the correct answer. This one is getting reduced to alcohol and other thing is remaining as intact. So I am very happy about this question. So I am sure all my dear students have underwent our lectures might have easily written this question. Okay, very good question. Now let's go to the question number 99. Again an organic question, that's a match the following from the chapter aldehydes and ketones. So you have the first question where carbon monoxide and HCl with the benzene ring. We know it's a clear case of Gutterman-Koch reaction. And I told you, my dear students, please remember Koch. So we know that CHO is present here. So surely this will be benzaldehyde preparation. I have told you this shortcut. So I know that this is nothing but benzaldehyde, Gutterman-Koch reaction to prepare benzaldehyde. A2R. You can easily see with the first option itself, you can get the answer. A2 is present only in option 2. So second option is the correct answer. Next one you can see. What is that? RCOCH3. We know that this is a methyl ketone. We know that all methyl ketones will undergo what reaction? Haloform reaction in the presence of sodium hypohalite, NaOX. If iodine is used, you will get iodoform as the end product. This will be oxidized. Correct? So we are learning this reaction. Okay, haloform reaction as a test for aldehydes and ketones. There we are learning all methyl ketones will undergo haloform reaction, or even if it is a secondary alcohol like this CHOH and CH3, this can even undergo oxidation, forming first step you can form the methyl ketone. So this can also undergo haloform reaction. Next one you can see alcohol with acid. You can easily see esterification reaction, alcohol with acid. It's a clear case of esterification. So second one is a case of haloform. Then the last one, RCH2COOH. Tell me what is that? RCH2COOH with the red phosphorus. You can easily see the red phosphorus is present along with the halogen. We know it is HVZ reaction where what will happen? The halogen will enter into CH. One of the halogen will enter here and you will get RCHX. with the COOH. Hope you are remembering all these reactions. So last one, it's a clear case of which one? Hell Vollard HVZ reaction. So the answer here is option 2 is the correct answer. So we are coming to the last question for the chemistry. So until now, all the questions we are able to solve it, right? So I hope my students, all of you have scored above 43. I'm sure about it. So in which one of the following arrangements give sequence is not strictly according to the properties indicated? So if you see here, you can see first one, all hydrates are given antimony. So we know that down the group, what will happen? Acidic character increases. So this is the correct thing, increasing acidic character. Now next one, we know that carbon, silicon, tin, lead, we know that it has increasing oxidizing character as you go down. So PbO2 is the most oxidizing in nature. So this is also correct one. Next one, increasing acidic strength. We have already explained. We know that iodine has a bigger size, so it can easily break the bond and release the H+. So Hi is the strongest one. So we can say that increasing Hi will be the highest acidic strength. If these three are correct, then the not correct will be option 4. Because here if you see H2O, H2S, H2SE, H2TE. So I know that H2TE is the most acidic. So it will be increasing Ka, but here they have given pKa. That is wrong. So I can say that this is the correct answer. So with this one, we are winding up our Neet 2021 question discussion for chemistry. I hope all of you have scored above 43. I'm sure about it. It was very easy question, completely from NCERT textbook and completely from our theory lectures, where we have focused exactly the same points. So I am again asking every student, don't worry. If you have a passion to become a doctor, Brainiacs Classes is there for you to completely support you. Just understand, just go through our notes, our lectures. It is completely NCERT, nothing else. And all the extra questions, previous Neet, previous AIMS, previous JE, previous beats, every question is completely solved. It's just, you just need to listen and write down the notes. That's it. So me, RSR, completely signing off, and wish you a good luck for the future ahead. Thank you.